Today we're going to be studying order of operations and the correct order of operations when solving math problems. Um, Before we do that though, I want to take a look at why we even have to have order of operations, why we have to study this. And I want to look at this example here as why we need order of operations. If you look at this problem, we have the same problem, 6 plus 2 times 9 in both cases, but two very different answers. If I do, for example, 6 plus 2 is 8. I believe I have the opposite one here. Let's come down here first. Let's go just left or right. 6 plus 2 is 8. And 8 times 9 is 72. That's how I could look at this problem and get an answer of 72. Another way I could look at this problem is say 2 times 9 is 18. And 6 plus 18 is 24. Okay? Same problem, two different answers. And that's why we study order of operations, and that's why, as mathematicians, we have a common language that we all understand and use so that we all are doing things in the same order and getting the same answer. Now, when you've heard of order of operations in the past, you perhaps have seen something like this. All right, or use the phrase PEMDAS. And that stands for do the parentheses first, then the exponents, then the multiplying and dividing, then the adding and subtracting. And that works as long as you keep a couple things in mind. And the biggest thing is, first of all, we do these things in this order. We do everything that involves parentheses. Then we do everything that involves exponents. Here's where misunderstanding often comes in, is, oh, next I do multiplying. That is not quite correct. I do multiplying and dividing are partner steps. So I do multiplying and dividing together in the order they appear from left to right. And then go back and do the same thing with adding and subtracting in the order they appear from left to right. There's also sometimes some confusion that'll show up with some parentheses issues because now that we're into middle school math, parentheses don't have to mean do this first. Sometimes they mean just multiplication. So we're going to take a look. If PEMDAS works for you, great. PEMDAS will still work. But we're going to take a look at another method that we looked at in class that some of you may consider using instead to avoid having to memorize the PEMDAS steps or what comes when and all that stuff. And the way we do that is by breaking a long problem into several smaller problems. And we can do that by, as we call it, bringing down addition and subtraction problems. Our signs, all right? And each addition or subtraction sign becomes a breaking point between each step. What I mean by that is, here's an example. Here's a plus sign. I have 5 plus 4 times 3. Need to know what to do first, when to do it. I'm just going to bring down a plus sign. And that breaks it into two separate problems. If I look to the left side of the plus, if I look to the left, the only thing over there is this 5. So I'll just bring that 5 down. If I look to the right, I have this problem. 4 times 3. 4 times 3 is 12. All right. Now that I've done those two separate problems, now I can put them together by adding. 5 plus 12 is 17. All right. If you take a look here, what that does is I'll go back to your PEMDAS quickly, and you may remember I need to do multiplying and dividing before adding and subtracting. And what bringing down the plus sign does is that breaks it up into doing my multiplying first. Here's my multiplying, which we did first, and then doing the addition at the end. But it breaks that up into two separate problems without having to do any memorizing. All right. Let's look at another problem with bringing down signs. Here we go. I have a 35. I'm looking at problem 5 here. I have 35 divided by 7 and parentheses 2. And I look at this example because it's an example, as we talked about, when you see a parentheses, but it doesn't really tell us to do something first. There's nothing inside the parentheses, it's just a 2. What the parentheses is telling us in this case is that this is a multiplication problem. But what I need to stress here is that it doesn't mean do the multiplying first. All right? If you go back to your order, multiplication and division are partner operations, which I do together. So I'm going to do my division and my multiplication from left to right in the order that they're written. 35 divided by 7 comes before the 7 times 2. Even though there's a parentheses there, the parentheses just means do what's inside the parentheses first. The only thing inside the parentheses is a 2. So just treat it like a multiplication problem. So I'll do the 35 divided by 7 first, which is 5. Now I take that answer times 2. Remember, parentheses, now that we're in middle school math, can also mean times. So I have 5 times 2 equals 10. And I throw that problem in there not to confuse you, but just as an example of there's where parentheses means times. All right, not do this first. If there were a problem written inside the parentheses, then you'd have go back to your original, do what's in the parentheses first. All right, next, we've got several things going on. We've got 42 on problem number 8, 42 divided by 6 times 2 minus 9. I'm going to go back to, again, bring down any plus or minus signs so that breaks them up till the end. Now, if I look at the left side of my minus sign that I just brought down, I have a fairly long problem. It's 42 divided by 6 times 2. That problem I need to do from left to right. So the first step is 42 divided by 6, which is 7. And then that times 2, which is 14. So everything on the left side of my minus sign equals 14. Now I'll look on the right side, and the only thing over there is a 9. So I just bring that 9 down. What I'm left with at the end now is 14 minus 9, which equals 5. So after all that, I have 42 divided by 6 times 2 minus 9 equals 5. Another example. We have in problem number 9, 2 times 8 minus 3 to the power of 2. I see one subtraction sign I can bring down. So I'll do my subtracting. On the left side of that subtraction sign, I have 2 times 8. And I know that 2 times 8 equals 16. On the right side, I see 3 squared. And I know that 3 squared, 3 times 3 is 9. So what I'm left with is 16 minus 9, which is 7. Okay. Doing things in the correct order. Parentheses first, then any exponents, breaking down any exponents, then doing all your multiplying and dividing together, then doing all your adding and subtracting together. And the last couple examples I want to look at here, which is 10 and 11, you can see highlighted, are going to put all of this together. All right, so let's go to problem 10 and 11, and let's put all of those steps together here as we look at problems 10 and 11. All right, first of all, I don't see any parentheses in problem 10, but I do see an exponent here. So I'm going to get rid of that exponent. I know that 2 to the power of 2 is 4. So what I like to do is just cross that out and replace it. 2 to the power of 2 is 4. Now, the next thing I see is that I have an addition problem, or addition sign, excuse me, that I can bring down and save till the end. Now that breaks this problem up into 2 much more manageable problems. On the left side, I have 5 times 4, because I've already taken care of the exponent part, so 5 times 4, which is 20. On the right side, I have 32 divided by 8, and I know that 32 divided by 8 is 4. My last step is to put the two problems I made together if I put the 20 plus the 4 together, I get 24. And you notice how the problem just kind of keeps coming down to the end, getting narrower and narrower. Work your way down to where you get to your one final answer. The last one we'll look at here is 3 times 6 minus parentheses 9 minus 8 to the power of 3. Now this may be a little bit different or something new when you see an exponent outside the parentheses, but we'll get to that in just a second here. We do know the first thing we have to deal with is parentheses, and I see 9 minus 8. This time it does mean do this first because there's a problem written inside the parentheses. So I do have to do that first. 9 minus 8 is 1. And because there's an exponent outside the parentheses, what that tells us is take whatever is outside the parentheses, or take the answer of whatever was inside the parentheses and do it to that power. So in this case, the answer inside the parentheses is 1. There's a to the power of 3 outside, so we're going to call this 1 times 1 times 1. Now, because 1 times 1 times 1 is still just 1, all of this, finally, is simply going to stay as 1. Now I've taken care of all of both the parentheses and the exponents. So what I need to move to now is looking for addition and subtraction signs. I do see a subtraction sign. So I'll bring that down. On the left side of my subtraction sign is a 3 times 6, and 3 times 6 is 18. On the right side, I had to do a lot of work to get rid of the parentheses and the exponent, but after I did all of that, I was simply left with just 1 on the right side. So I have 18 minus 1, and 18 minus 1 is 17. All right. Now, next thing I want to look at is what does this look at? So this is a review of your process a little bit. All right. Whether you use PEMDAS or you want to experiment a little bit with this method of bringing down plus and minus signs to save those till the end. All right. You're doing parentheses first, then any exponents, followed by multiplying and dividing left to right, and finally adding and subtracting. What's that look like in a word problem? This can help you out with breaking long word problems like this lawn area problem into several small steps. Let's look at this. It says the Solomons need to find the area of their front and side yards since they want to reseed the lawn. Both side yards measure 3 meters by 10 meters, while the front yard is a square with a side of 9 meters. They do not need to reseed a portion of the front yard covering 16 square meters where a flower bed is located. What is the area of the yard that the Solomons want to reseed? There's a lot going on in this problem, but let's visualize it first. If this is the house, okay, we know that both side yards are 3 meters by 10 meters. So I'm just going to draw two little rectangles here. These are the two side yards, and they're both 3 by 10. So that's part of the yard. And we know the front yard is a square that is 9 by 9. Okay. But if that's not enough, we also need to take out 16 by 6 or 16 square yards where there's going to be a flower bed. So we'll take that away. Here's an example of where order of operations can help us write one long problem broken into smaller steps. So let's start with the left side. And we know to find the area of the left side, we want to know how much total area we need to seed. The area of the left side is 3 times 10. The area length is 10, the width is 3. We're going to add to that the area of the right side. And the area of the right side is also 3 times 10. All right. I'm just going to slide this over a little bit because I'm going to run out of room otherwise. So it's still my 3 times 10 plus 3 times 10. Give it a little more room here. Now let's go to that front yard. There's a couple steps with the front yard. First of all, the front yard is a 9 by 9 square. So I can do that part. But I'm also told that there's this little bit here of 16 square meters that doesn't need to be seeded. So I have to take that 16 away. Here is my problem that represents the total area of the yard. Now I can break this up. I see a plus sign here, I'll bring that down. I see a plus sign here, I'll bring that down. And I see a minus sign here, I'll bring that down. So let's take my first chunk. My first chunk is 3 times 10. 3 times 10 is 30. Goes there. I'll take my second little segment, and I have 3 times 10 is 30 again. There's that. Next, I'll go to the third set here. And if you see this third space, it has a 9 times 9 in it. I know 9 times 9 is 81, so I'm going to put that there. And finally, if I go to my last segment here, all that's there is a 16. So I'll just put 16. Now I can piece all this together. I have 30 plus 30 is 60. And I'm going to add to that this 81. So 60 plus 81. Okay. And finally, minus 16. So I'll take my 141 and I'll subtract 16. So what I'm left with is that the Solomons need to seed 125 square yards of lawn. Right? Again, that takes a very long process, and you can see it helps to visualize it, to draw it out as well. But you can see with my long problem, 3 times 10 plus 3 times 10 plus 9 times 9 minus 16, if I use order of operations to break that into several small problems, it becomes more manageable. And to finish things up, we're going to go back right where we started. If you take a look, so now that we're all speaking the same language, now that we're using mathematical order of operations, what is the correct answer? Well, we now know, going back to our correct order of operations, that we do multiplying before addition. Or if we're looking, we bring down addition signs. On the left side is a 6. On the right side is 2 times 9, which is 18. Right? And 6 plus 18 is 24. So if you decided that 24 was the correct answer for this problem, you were correct. Okay? And you are using the correct order of operations. And to recap that one last time for you, order of operations in math, do the parentheses first, followed by any exponents, and then multiplying and dividing as partner operations left to right, followed by adding and subtracting as partner operations left to right.